K3s is the lightweight open source Kubernetes distribution designed to work on premises and in the cloud. It's tiny, so you can use it in resource-constrained environments like IoT and the edge, and it's fast, so you can use it in places where you don't need all the baggage that comes with a full-size Kubernetes distribution. I run K3s at home and also in the cloud. When I was a kid, my favorite toy to get at Christmas time was a Stomper 4x4 truck, and it always came with batteries included. This meant a lot because I could immediately start playing with it. K3s is the same way. Everything ships as part of a single tiny binary, and it unpacks to include Containerd, Kubernetes, and manifests that install the open source software that you need to use the cluster right away, like Traffic Proxy as the ingress controller. You don't have to prep your hosts in any way, and K3s installs practically anywhere on both ARM and Intel architecture. If you can put Linux on it, K3s will probably run there too. K3s was originally created by Rancher Labs, now part of SUSE, and they donated it to the Cloud Native Computing Foundation. It's the only Kubernetes distribution that the CNCF owns, and that says a lot. The act of donating something to the CNCF isn't like walking by and just throwing it over the fence. The CNCF reviews submissions and then they choose what they accept. By accepting K3s, they've told the world that this lightweight distribution of Kubernetes has a place in their landscape of cloud-native applications, and that its existence serves the community. So while there are other lightweight Kubernetes distributions like MicroK3s and K0s, only K3s has the CNCF's stamp of approval at this level. So back to the batteries included bit. K3s has 4 special features. Let's call them pillars. And these are working for you out of the box. They are the service load balancer, the manifests directory, CRDs for Helm, and Traffic Proxy. The Service Load Balancer is an open source project called ClipperLB that's part of the overall K3s project. If you're wondering about the name, it comes from the early days when K3s was going to be called Clipper. When you deploy a cluster into a cloud provider, the Cloud Controller Manager communicates with the cloud provider's API, and when you request a load balancer service, Kubernetes provisions a cloud load balancer for you. The cloud provider then bills you for this resource until you destroy it. When you run Kubernetes on premises, you have to use an external load balancer of your own, either something like an F5 Big IP or a NetScaler or an external box that you build running something like HA Proxy or Nginx or Traffic Proxy. Some commercial providers give you a cloud controller manager that will talk to their hardware, but in most cases you'll be doing double work. You'll configure Kubernetes to listen on a port, and then you'll configure a load balancer to receive traffic from some external source and send it to that port. Remember that K3s is Kubernetes for resource-constrained environments first, so it's optimized for single-node clusters. It uses SQLite as the data store, and when you create a load balancer service, Clipper opens those ports locally on the cluster nodes. From the moment you fire up a K3s node, ClipperLB makes sure that you can connect to Traffic Proxy listening on port 80 and 443. The way that K3s unpacks to be so powerful is that it includes manifests that are placed into a special directory on the server. K3s monitors this directory, and if it sees something new there, then it installs it. If it sees that an existing manifest changed, then it updates it. It won't uninstall stuff that you remove, it just installs things and then updates them. This is a great way to bootstrap a server with a configuration management system. If you create this directory before you install K3s, then in addition to installing its own resources, K3s will install anything that you put in that directory. And you can even use it after K3s is installed. Just drop new stuff into that directory and K3s will install it. Installing via manifests is one thing, but installing via Helm is the standard way that we do things in Kubernetes. So how do you automate what's normally a command that you run from a terminal? K3s gives you the Helm chart custom resource for this. When you convert your Helm instructions to the format in this manifest, K3s installs the packages using an internal Helm controller. Once installed, you can see and interact with them exactly the same way as if you installed via the command line. For complex Helm values, or to alter a Helm chart resource that ships with K3s without altering the resource itself, you can use the Helm chart config custom resource. This is how you would change the static configuration of Traffic Proxy in a K3s cluster. The final pillar that K3s includes is, of course, Traffic Proxy. This is a powerful cloud-native edge proxy that can do tremendous things for you. It's what we're going to talk about in this class, So let's dive in and see what it can do.